Today's video will be on lesson 1.3 compound interest future value, focusing on our examples. For example 1, we have both Jolie, age 50, and her daughter Lena, age 18, plan to invest $1,500 in an account with an annual interest rate of 9% compounded monthly. If both women hold their investments until age 65, what will be the difference in the future values of their investment? So for this one, we have two different people, so we're going to do two different calculations. For Jolie, I'm going to show you how to use the formula. And for Lena, I will show you how to use the financial calculator on the computer. So for Jolie, so actually, let's do this. I'm going to cut my screen in half here. And we're going to do Jolie on one side. And we're going to do Lena on the other. So for Jolie, we need to have an A, a P, an R, an N, and a T for doing compound interest. And again, just a note for how I know this has to be a compound question, it specifically says compounded in the question. So let's see, for Jolie, we have that she invested $1,500, and so that's our P, our principal. We have our interest rate. And actually, just to fix it based on my notes, we're using I for interest rate now. And so it's going to be 9%. And that needs to be written as a decimal, so that's going to be 0.09. And then for our N, which is the number of times compounded in a year, it says it's compounded monthly. So that is going to be 12 times each year. And now for the term, we have that Jolie started at age 50, and they're going to pull the money out at age 65. So the difference between 65 and 50 is 15 years. So our term is going to be 15 years, and our future value is our question mark. So for the formula that we're going to use, A is equal to P times 1 plus I over N raised to NT. Okay, so our P is 1,500. We have 1, which is always 1. Our interest rate is 0.09 over number of times it compounded, which is 12. That's raised to our number of times it compounded, which again was 12, and our term, which is 15. So now to do the calculation, I'm going to pull out my calculator. Bring that on screen so you can see what I do. So I start with the fraction first, the 0.09. I divide by the 12, it equals. Add the 1, it equals. I raise that, so I use my exponent button. Did the 12 times 15, so I'm going to put the 12 times 15 in brackets, just to make sure my calculator does what it's supposed to. It equals. And now I'm going to times that by 1,500. It equals. So for this one, we get our 5,757.06. And just a note, we're working with money, so we're always rounding to 2 decimal places. So by the end of her investment, Jolie will have that 5,757.06. Now for Lena, we are going to bring up our financial calculator. So here's the financial calculator. And just a note, or just a reminder, I guess is a better way to put it, this right side should say no and 0 for everything, and then all our work is going to be done on the left side. Okay. So let's see if I can get this all on the screen so I can read and type in at the same time. Yeah, pretty close. Okay. So we have our starting amount, which is our principal, so that's the 1,500. We have the periodic investment amount is 0 because we're not, like, we're putting in that lump sum of 1,500 and that's it. We're not adding any other money through the length of the term. Okay, so the number of cash flows, what we have to figure out for that one, and I'll bring up my calculator for this as well. So we'll have a calculator and we'll have, there we go. Okay, so clear what's here before. So Lena starts this at age 18 and ends at age 65. So I'm going to do 65 minus 18 to figure out how many years this covers. So it's 47 years altogether. And in that 47 years, each year is compounded 12 times because we're doing monthly. So this number of cash flows, it's each time the calculation is done. So again, just to say it again, we're doing monthly, so 12 times in 1 year, and that's going for 47 years. So I'm going to do the 47 times 12. So the calculation is done 564 different times. So I'm going to add that to my number of cash flows. My interest rate is 9%. And when you punch it into this calculator, you leave it at 9%. The goal amount is unknown because that's where we're calculating the end result. For today's date, I'm just going to switch it to the start of the month. And we're doing it monthly, so the first cash flow or the first calculation will be done a month later. So that would be 10/01/2021. And then compounding investment is going to be monthly. So then scroll down, I hit calculate, and ignore what's down here, focus on what pops up in this space. And so we're left with our gain 101,461.71 cents. So I'm just going to write that down for Lena so I remember. So it was 101,461.71 cents. And now the final part of this question is, what is the difference in their future values? So Lena gained this 101,000 and Jolie gained 5,757. So I'm just going to subtract that because difference means subtract. So take the 101,461.71 cents minus 5,757.06. And we end up with $95,704.65. And so that is the difference. So yeah, Lena is going to make the more money because hers goes for 47 years, whereas Jolie's only went for 15. Okay, example 2, we have both Berta and Chris invested $5,000 by purchasing Canadian savings bonds. Berta's Canadian savings bond earns 8% compounded annually, while Chris's Canadian savings bond earns 9% compounded annually. We're going to estimate the double time for each CSB. So yeah, we have two people, so I'm going to cut my screen in half. We have Berta and we have Chris. And so key is we're estimating doubling time. So to do this, we're going to use the rule of 72. And then to do that, all you do is take 72 divided by your interest rate. So Berta's was 8%. So 72 divided by 8 works out to be 9. So it's going to roughly take 9 years to double. Whereas Chris, same idea, you do 72 divided by his interest rate, which was 9, and that works out to be 8. His will double roughly in 8 years. And we'll be close with the ballpark because we're compounding annually. There is a chance that we're off by a little bit, but because it works better with the monthly. Okay, so to finish off, we're just going to verify that we are correct with this. And just for time's sake, I will do this on the financial calculator. So we're investing 5,000 at the beginning. Our periodic investment is still 0 because we're not making regular payments into this. The number of cash flows, and so that is unknown. And the annual rate of return, so we're doing BERTA, is 8%. Goal amount, so we're doubling that 5,000, so we're trying to reach 10,000. And we're going to be doing this annually. So for my dates still leaving, today's date for the 1st of September, but then the first cash flow is going to be done a year later because it's annually. So that's going to be 09, 01, 20, 22. So I hit calculate and plugs in for a number of cash flows, works out to be 9. So just a note for this, we don't have to do any extra calculations for this one because it is annually. So it's just once a year for and 9 times, so that'd be work out to be 9 years, which matches what we did in part A. If it was, say, monthly, and you got, I don't know, 144 cash flows, then you would have to do 144 divided by your 12, and that will tell you how many years. Because yeah, again, this is for number of cash flows is the number that fits in there is your years times the number of cash flows. Okay, just to finish off, we will do Chris. So everything's going to stay the same for Chris, except this is going to be unknown, and his annual rate is 9% instead. Hit calculate, and his works out to be 8. So his is 8 years, which matches our estimation. So in summary, to calculate the future value of an investment, use the following formula. A is equal to P times 1 plus 1 over N raised to N times T. To calculate the interest earned, take the future value minus the principal. And the rule of 72 is a simple strategy for estimating double time. To do for the practice questions today, what I will tell you is start using the formula to begin with. Do the formula as many times as you need to understand it, and then you can switch to using the financial calculator. And that ends this video.